Very beautiful.
I love it.
Thanks for the explanations.
Welcome, sir. So let me welcome everybody to this edition. So we have been discussing the non-parametric counterpart of t-test. At the exception, we talk about t-test, the t-distribution itself, then the t-test, the different types, and situation where the assumption for using the t-test cannot be met. So we have option to use non-parametric test. We have option to also, first of all, rely on the robustness of the test to still continue using the parametric test. You cannot do that. We have option of using the non-parametric test. The option of transforming the data should be the last one, even should be avoided. So we have been discussing this non-parametric test, and we said that each of the parametric tests has its own counterpart, non-parametric counterpart. So when you look at the three scenarios for comparing mean, one sample, that is when you are comparing one sample with maybe a parameter in the population, you have access to only one sample. In that case, that is one sample test. So the way we have in parametric, we also have in non-parametric. You now say, okay, for one sample t-test, the non-parametric counterpart, Wilkinson rank pair sign rank test, Wilkinson sign rank test, or sign test. They are called, though they are different, but they are very close. Sign test, Wilkinson sign rank test. That's because it's the same thing. Hold on. So it's the same thing with what you use for comparing pair observation. So when you look at pair observation also, instead of using pair t-test, instead of using pair t-test, you use Wilkinson sign rank test also. So it's a little bit different from what you have in parametric test. In parametric, you have one sample t-test, you have independent sample t-test, and you have pair t-test. And the way you calculate all of them differ. Those t, if you really look at it, the one sample is still close. One sample t-test and pair sample t-test, they are still closer. If you look at the formula, because you are dealing with one sample. Now, even the pair is one group of subjects. Don't let me say, because when they use the word sample, they talk about the observation that have been taken. Like pair samples mean the same group of people, you take your observation 2 times. So when it says pair samples, it's still plural, pair sample, you pair the sample. So it's not human being, the subject you pair, it's the observation you pair on a group of subjects. Whereas in one sample, it's still, so when you compare with the one sample, it's still the same group, one group of people. So the first one, the one sample t-test, compare the one sample with a parameter, either a mean, if it's parametric in the population, or a median, if it is not parametric in the population. While the pair sample t-test, in one group of subjects, the measurement 2 times. So in the same, if you want to now use the non-parametric counterpart, the logic there that is the same statistic that goes, you see, when we go through, you see the reasons like that. It's the same statistic that you use to run the one sample and pair sample for non-parametric, the same. You're going to see that that particular median they give, the parameter you give for one sample will be a constant. It will serve as if it's the second pair, because a constant means that it's going to be the same, because you are minusing. It's going to be the same for all the subject. We are going to see it. Now we have looked at the independent sample test for the non-parametric counterpart, which is the Wilkinson rank sum or Mann-Whitney-U test. We have looked at it. We also look at the pair sample counterpart, which is the kissing sign rank test. But what we want to discuss today is there's another test called median test. The median test of we have two types. We have the sign test and we have the mood median test. So that sign test goes for one sample T or pair sample T. You know, for one sample and pair sample, that is non-parametric. While the mood median goes for independent sample. You're going to see. So let's quickly look at situation that were around the use. Just 1 minute. Sorry, I'm having with NEPA and all those issues with NEPA. I'll resolve it. So now I want to quickly look at comparison of one sample with a population parameter. Of course, the population parameter here, when we are talking of non-parametric test, is the median. We would like to talk about median rather than the mean. Now, but you see that it's not all the non-parametric tests. All the one we have discussed, none of them use median. The Wilkinson, ransom, and Sarah, they didn't use median, they didn't use mean. So sometimes when people say that non-parametric is about median, it's not actually absolutely true. It's not all of them. Because there you will not even see mean, you don't see median. So it's just comparing. So it's just comparing the two, ranking the groups and comparing. Now, sign test is a type of median test, as I've said. Then Wilkinson sign rank test. You know, this sign rank test is also used to compare two pair observation. That is, it's a non-parametric counterpart for pair t-test. So in this case now, we are also using it for one sample test. So this one sample is, but in this case, is comparing the one sample with the median in the population. The sign test uses only directional information, while the Wilkinson test uses both directional and magnitude. If you look at it, we have the Wilkinson, we have done it last time. You know, it's the same thing. For the what we actually did for pair sample is the same thing. Even when you are considering only one sample, you will see that the Wilkinson look at the direction. Direction doesn't mean that you remove one from the other. You want to know how many are negative, how many are positive. Because when you remove one group of observation from the other, those values that are higher, if what you remove, the group you are removing, the value that are higher will give you negative sign. The value that are lower will give you positive. So that is what we call directional here. So the logic is to know how many have negative, how many have positive. You know, the Wilkinson will still add them together, but the sign doesn't do that. It just look at the direction. Somebody is making us. I have to thank the person and mute that person. Somebody is making. Please mute yourself. Please, okay. Now, because of that, the Wilkinson test is more powerful statistically because it looks at the direction and also the magnitude. So let's quickly look at a scenario here because some of these things is better understood with a scenario. No, it's better you are practical for people to understand. In a law college, a random sample of 10 student mark is noted below. Is there any evidence that at the 5% confidence level, sorry, it's 95% confidence level, sorry, or should be 5% significant level, suggest that the median mark is greater than 65. 5% significant or 95% confidence level. Now, look at 1, 2, 3, 10 students, and these are the score, they are marked. And you are comparing it with a medium score or mark of 67. Maybe that was the marks in the previous year or in another law school. Whichever way you are comparing this group with the median of, you cannot say another group now, but in a separate population or the same population before. Now, how do you do that? You see, you have only one set. If you remember, when we do one sample t-test, it's the same logic, because that one, it will give you the mean in the population. So all you need to do in the formula, you just you calculate the mean for your sample and remove the mean from the population from it. The same thing here also, you remove the median from each observation. It's different. The other one, for the one sample T, you will have to calculate the mean of the group and now remove the mean from the population from it. But here, you first of all remove the median, this median from individual. It's not from the median now, it's from individual observation. So look at it, calculate the difference, ignoring the sign, and okay, let's just look at it. So the median is 67. So if you remove 67 from each of them, look at it, difference. It gives you all this value. The value down here, 4, 12, minus 27, 3, 15, 5, minus 7, 9, 2, 8. You see, 2 have negative value. Those two, you will see that the value you are removing 67 from actually lower than 67. And that is why you're having negative value. Look at this one, 40 and 60. That's when you remove 67 from them, give you negative value. The rest, they are higher than the 67, give you positive. So the same value I put here, the difference. Then you now rank the difference. So from the smallest to the, irrespective of the sign. Rank it, you rank them. The smallest is 2, 1, you give you 1. The next one is 3, you give it 2. The next one is 4, you give it 3. The next one is 7. Even though it's minor, it doesn't really matter. It's 7, you give 5. So the next one is 8, you give 6. The next one is 9, you give 7. The next one is 12, you give 8. Then you now have the last one, 27. Okay, we have 9 also, 15, 9. Then the last one is 27, give 10. So you now separate the rank. We have rank for negative and positive. So all those ones that are positive, you see their rank, separate line. The ones that are negative, there are 2 of them, separate them. So you'll be able to add them together. When you add them, it gives you the rank for the positive 40, the rank for the negative 15. Look at it, 15, 10 and 5, 15. Whereas if you add all this, it gives you 40. So, and with his own statistic is whichever one is smaller is the statistic. So the smaller, not smallest per se, smaller value between 40 and 15 is 15, and test statistic is 15. And you know that, look at the way the table looks like. If the sample size is 10, n is 10, the critical value is around for 0.0, okay, this one test, even for 0.05, level of confidence, level of significance is 8. So it is when that statistic is less than 8. We already said that this Wilkinson witness of they are the only statistic that the smaller the significant. So the smaller, then the smaller the p-value. The other statistic, the bigger the statistic, the smaller the p-value, the more the significant. So now we expect for these samples at 10, we expect the value to be less than 8 or 8 or less to be significant. So that is why it's not significant. Since the test statistic is greater than the critical value, so there is no significant evidence that the median rank is greater than 67. So there's no significant difference. That's just it. Very simple. Well, if we are going to run it. Okay, I think the output I removed. Did I remove the output? Oh my God. maybe I will run it. I will run it here now. But let's look at median test. Okay, maybe I should just go ahead and run it. Sorry, I thought I put the output there. Let me just run it there on the SPSS. You can see the way it worked. So let me just quickly run it. So I think this is the data set. I think everybody is seeing it. Let me just quickly do the SPSS, analyze, go to non-parametric, legal value.
It's the median test. It's median test we are seeing. Okay.
What do you see?
Oh, okay, yeah, we are seeing it. We are seeing it now.
And SPSS now. I say I want to run.
Yeah,
I didn't put the result there. I just want to run so that people see the result. I didn't put the result there.
Okay,
I thought I put the result there. Just see the way it is run. So this is the sad data set. Can you see? It's even good at come to explain. If you see what I told you, for each of them, that median is constant. You have to put it 64%.
Yeah.
Because it's constant for all of them. So that's the way it works. So we now put analyze non-parametric dialogue, legacy dialogue, then two related. You can see you treat it as two related. You not treat it, that's one thing. You not treat it as one sample. Two related. Because if you look at it, what is you are relating the mark with the mean, with the median rather. You know, when you click on it now, you move the mean, the mark, the median. So the median, as if they appear, you are pairing the median. Because the median is constant for all of them. So look at Wilkinson. So Wilkinson by default, that is the sign rank test. This is sign test itself. So when you click, let me share the
output here.
Output. Where is the output? Maybe somewhere. Okay. Look at the output here. You can see Wilkinson test. You will see that how many have negative. Oh, sorry, it's the arrangement. It's not positive, but how many is 2? It's just the same thing. Is the way I arrange it is different from the way I arrange it there. But just know that it's going to be the smallest statistic, the smaller one that will be the statistic, 15. So you can see
which is
15. And sign test also is not significant. It's giving the same thing. Yeah, the same thing. Then the only thing that the p-value differ slightly, but both of them are not significant. That's what we have seen, that they are not significant because the statistic is not small enough to be significant. That's just it. So let me go back to the slide so that we continue. Okay. Yes. So that is the sign test. The next one we're going to be looking at is quite interesting. The other type of median, the median test. This median test is a non-parametric test that is used to test whether 2 or more. Can you see 2 or more? It's not even only 2. You know, we are talking of comparing 2 means here. T-test is about comparing 2 means. We have not been discussing ANOVA, which is comparing more than 2 means. But this median test is a non-parametric counterpart of both the independent t-test and ANOVA, because more, that is 2 or more independent group. Can you see different in their central trend? When they say central trend, they are talking of mean, mode, and median. So here, median. The principle of the test is that if 2 samples have the same median, they should have more or less, if they have the same median. If we now match all of them together and now arrange it, when you now have a median, common median for both of them, if they are actually the same, they should have equal number above the median and below the median. That's just the logic. And that is the principle here they use here. So irrespective of the two groups, you merge it together. You now have the central media. You now see how many of this one is above the central media, how many of this one is below. If actually they are the same, you see that as many that are above, if let's say we have 5 that are above the median in this group, it should be around that 5 that should be above the median in the other group, and vice versa. Look at it. The private bank is an example. This one is an example. Now, a private bank is interested in finding whether the customer belonging to 2 groups differ in their satisfaction level. So, fortunately, I just have 2 groups here now. I decided not to have 3 because we are not actually talking about comparing more than 2 groups. But the test can be used for comparing more than 2 groups or 2 groups. So the 2 groups, the customer, they look at, just a minute, this person is just, please, I'm in a lecture. We'll talk later, I'm in a lecture. So a private bank is interested in finding out whether the customer belongs to 2 groups differ in their satisfaction level. So the 2 groups are the people that are holding savings account, current account holder. So look at them. Yeah. You have current account. So they sample 20 and the sample savings 20 also. Separate group of people. And they try to assess the level of satisfaction using the Likert scale from 1 to 5. Even though the Likert scale from 1 to 5, but when maybe they have 20 questions or whatever, if you had the aggregate score, what they put here now is the aggregate score. What you are comparing is not the individual score for each question that is on the Likert scale, but aggregate score for all the questions. So that is the score you have. So try to see which one score higher, which one have really have more satisfaction. So let's say this one now, some people will argue. They say because originally, just like what Prof was saying before, originally they may begin to argue that the score was on ordinal scale. Yeah. Because it's on ordinal scale because Likert scale 1 to 5. Even though you are adding it together, you do not use a parametric test. Well, so if you follow that, we decide to use parametric test, median test. So when you look at it, how do you compute it? So when you arrange, look at this table now, this first one, arrange it in descending order or whichever way. Sorry, either ascending or descending order, whichever. If you want to get the median, it's either way. So this one is arranged in descending order. You see now, they are mixed all of them together. So if you now have 40, which observation will be in the middle? It will be number 20 and 21. So number 20, and if you look at it, this is number 20, 62, number 21, 61. So when you now, the median is 62 plus, since there's no one value that is median, you have to calculate the average of the two. 61 plus 62 divided by 2 give you 61.5. So the median for the group now, for the 2 group together, combined median is 61.5. So if you look at it, how many, if you can, I've denoted those ones that are above the median, I put them in blue. The one below the median, put them red. If there's any value that is equal to the median, that one will be 0. You will not be used. You will not use it. You will not belong to any group because it's neither above nor below. But there's no one like that. We have the blue. So when you now look at the groups now, for the current account holder, 8 has value, if you count it, have value above the median. 1, 2, 3, 4, 5, 6, 7, 8. Whereas the other one is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see? So that shows that 8 half above median, 12 below. 12 half above, 8 below. So it now give you a T table. If you cross tabulate, it gives you a 2 by 2 table. So this one is telling you something. So this term is chi-square. So once you see 2 by 2 table, when you see contingency table rather, then this one will be 2 by 2 table because it's about above and below. It's just two groups. You have divided into 2 groups. So you now have 2 by 2 table like this. So the 2 by 2 table, when you calculate the chi-square, they give you, you know, if you remember, Pearson chi-square can be calculated, then you can make yield correction, whichever way. So the Pearson chi-square from our, I don't just bother because we have done that extensively. If you apply the formula for Pearson, it gives you 1.6 Pearson chi-square. If you correct for the yield, it gives you 0.9. And the degree of freedom is 1. You see, it's 1. So if you look at it, the output, you run it, look at the output. Look at the output. So it tell you, okay, look at the for current account, you see, the one that are above the median, 8 for savings, below or equal to the median. So some people, even when it is 0, somebody say that you can use it below, we count it as below. Then 12 or 8 and 8 here. So look at the chi-square. Look at the chi-square. This is the Pearson chi-square 1.6. And look at the yield corrected chi-square 0.9. Of course, the degree of freedom is 1. The critical value for chi-square at degree of freedom 1 is 0.86. 3.84 rather. 3.84. I think I said here. 3.84. So the value is it's not statistically significant. So there's no difference in the level of satisfaction between the current account holder and savings account holder. That's just a summary of it. So from last week that we have been on this series, people have been calling me, asking me questions. I think people are confused. That's why I just try to summarize statistical table because people were not following. When we started, we were talking about we talk extensively about the basic concept, the descriptive statistics, probability and normal distribution. We talk about inferential statistics and many things. Now, when we started, after talking about inferential statistics, we talk about assumption and hypothesis test. So the hypothesis test now, we talk about 2 different types of differential statistics. We talk about hypothesis testing and confidence interval. And from there, after the initial talk, we now started with the statistics. So I think I explained, I gave a table in the lecture on assumptions around hypothesis tests. Which type of test do you carry out? I don't know, maybe it's a little bit complex. The people seem to understand, but some people, the question I was now getting from people, maybe to redraw, and now draw this table for people to understand the type of test, because it's like people are lost. What I did after those initial one, what I did for the first 2 weeks was to talk about categorical variable. When you are looking at association between 2 categorical variables, look at this first row now. When your exposure and your outcome, because when you want to look at association between 2 variables or a relationship between 2 variables, one must be exposure, one must be outcome. The exposure is the independent variable, the outcome is the dependent, the one that depends on the other one. And I talk extensively, like for example, if you say blood sugar, blood pressure, and salt intake, we know that salt intake can lead to increase of blood pressure. So the dependent variable now is the blood pressure, depend on the salt. It's not the salt that depends on blood pressure. We also talk about, when we talk about sex and employment status, when you are comparing sex and employment status, the employment status cannot determine somebody's sex, but somebody's sex can determine somebody's employment status. In that case, when you are looking at the relation between sex and employment status, the exposure will be the sex, outcome will be the employment status. Or you say independent variable is the sex, the dependent variable is the employment status. We discussed that. So whenever you are looking at the 2 variables like that, if the way you summarize the 2 variables are, they are categorical, like issue of sex and employment status. Naturally, they are categorical. Sex, male or female. Employment status, you are employed, you are not employed. So you see, they are categorical. So when you're looking at association between 2 categorical variables, so what you do is chi-square. And if other analysis you can do, especially if it is 2 by 2 table, it calculates relative risk and odds ratio. And that was why the initial training I had, the weekend training, and we treated all this for over 2 weeks. And the 2 weekend also, we now did training on how to run all these different type of chi-square. I think we talked extensively about. I think we even calculated up to about 8 different type of chi-square, Pearson chi-square, Yet corrected, likely ratio chi-square, likely chi-square for goodness of fit, McNema chi-square, McNema Bowker chi-square. We talk about chi-square for train. No, we calculate all of them. And when chi-square is not valid, when we use Fisher exact. And we also went to calculate relative risk and odds ratio for 2 by 2. We did that extensively. So the logic was for me to first of all finish. The logic is to finish categorical variable outcome, categorical outcome. When you are talking of categorical outcome, then with categorical exposure, and that was what we did. And in this series, from the last 2 weeks now, we now look comparing means between two groups. But the first one we did was comparing proportion between group. Can be 2 groups, 3 groups, 4, it doesn't matter. Can be many groups. But when it comes to means, how you compare means between 2 groups is different from how you compare means between 3 or more groups. And that's why what we are treating we finished today is comparing means. What do you summarize with means? Is it not numerical variable? So the outcome is numerical, but the exposure is 2 categories. That's why we're talking of 2 means. So that's what we're talking when we talk about theta, all the different types of theta, all these non-parametric counterpart is treated here. And that is why the next one I'm going to be the series I'll be talking about will be comparing mean between among more than 2 groups. That's where ANOVA comes in. So the parametric one ANOVA, one way ANOVA, factorial ANOVA. The non-parametric counterparts of ANOVA are Kukawalis, median. You know this median we just did now. We say it's for both 2 independent groups and for more than 2 groups. That's why the median also come here. Then Friedman ANOVA when it is 2-way ANOVA or factorial ANOVA. So when you now come, if you look at it now, the first one was categorical. The exposure categorical, outcome categorical. The second one is the exposure categorical still. There are 2 categories of the categorical. Then the outcome is numerical. This one now is categorical exposure, see numerical outcome, but this one more than 3 or more. Sorry, it's supposed to be 3 or more, not just greater than 2 or 3 or more. I'll correct it. Yeah. Then numerical, when you now come to numerical categorical, because you may ask question, is there no situation where your exposure is numerical and your outcome is categorical? In that case, you will not see any bivariate analysis here that correspond with that, because except logistic regression as a bivariate analysis. Bivariate means that you just have one outcome, one exposure. You're having 2 variables at the same time, one outcome, one exposure. That is bivariate analysis. So you know, see, what you can do is that you can still do the chi-square. If you now use numerical, you now categorize it. This exposure, if you categorize this exposure, you can see now treat it in the first group. Exactly. Once you categorize the exposure, you can treat it. That's what we usually do when we do age group. So we're able to do chi-square, even when the age in that case is an exposure, because most of the time age is a confounder you use as social demographic. It's not the outcome you are measuring. The outcome may be maybe prevalence of hypertension, prevalence of anemia, which is categorical, but you now have age, which is numerical. For you to be able to run bivariate here, apart from logistic, what you do is to now categorize age. When you categorize age group is not numerical, it's categorical. It's different from the original age. When you categorize it, you go into group, you can now run the analysis and now do the chi-square. It will now do as if you are looking at association between categorical and categorical. Now, when you now come to numerical, you know here you have categorical. Now, when you now see numerical, both of them, they are numerical. There's no category there. They are all number. It's correlation that look at it, but in correlation, you don't want to say you are talking of outcome on exposure. No one is outcome, no one is exposure. But the two variables, they are numerical. So we are talking of correlation. But in a situation when the variable you are dealing with, they are continuous variable. They are not discrete. They are, let's say, numerical variable originally, and they are not ordinal. Is Pearson correlation. And is this same person that first of all described chi-square, Pearson chi-square, that first of all described chi-square? I think we talk about it, Pearson. Then there's a situation, there are some situations where the data was originally ordinal, like all this like SK. No, you give number. There is number. It's a number. You have given number, but originally is that number is a code, is arbitrary. It's arbitrary. That's not the original value. So in that case, the correlation you do is payments or candle. So when you get there, you see. Now there are situations. Okay, before I talk about the last one here, all this one, why I separate logistics is that most of all this analysis, they are normal like screening. When you do, maybe you want to look at factor responding for something, you can do all these tests. You can only do relate it one by one. Let's say prevalence of anemia. You can only look at association between anemia and something separately, and sex and anemia separately, location and anemia separately, different thing, income and anemia separately. You do all of them separately because these are bivariate tests. Bivariate means that per time you are looking at the exposure and the outcome with one exposure, one outcome, one exposure. So sometimes you may see a lot of things are statistically significant. How do you know which one is confounder? That is where logistics comes in. The simple logistics just like it's a bivariate also. It's like the outcome is one, the exposure is one. It's just like all these other one, simple logistics. But what we are saying is that whenever your outcome is what determines the type of logistic regression you do now is the type of outcome. So if your outcome is categorical, it's logistic. If your outcome is numerical, it's linear regression. Logistic linear regression. So in logistic, when you do simple logistic, it's more like screening still also. It's form of advanced screening. For you to actually remove the effect of confounder, you may have to run many outcome, many exposure. One outcome, but many of those exposure, you combine it, that would be multiple logistic. Not a multiple regression, either logistic or linear. Multiple regression. It's the multiple regression that is called multivariable regression. Multivariable, it's not multivariate analysis. That's the mistake. If you even see in some book, they still put multivariate. That's what we say multivariate analysis. No, it's multivariable analysis. If you really want to know what I'm saying, you have to look for standard textbook on statistics, not anyhow textbook. I will just write it. Look on one and get standard textbook. You will see they are called multivariable analysis because only one, there's still one outcome, but many exposure. But in a situation, you can have it for both logistic or linear. It doesn't really matter. What differentiates logistic and linear is the type of outcome. When your outcome is categorical, it's logistic. When this is numerical, it's linear. But if you look at the logistic also, we have when there are the category of the outcome are two, it's binary. When there are more than two, it's multinomial. Even when it's more than two, they are ordinal also, they are order. Like a socioeconomic status is an outcome, maybe it's an outcome. Is more upper, middle, lower. It's more than two outcomes, but it's in order. That is ordinal. Ordinal. So you can have it simple or multiple like that. Now, if you now come to a situation where you can have more than one exposure, more than one outcome at the same time, this is what we call multivariate analysis. That is the multivariate, the real multivariate. That is on both sides. The bivariate, one on one side, one on the other side, one outcome, one exposure. They multivariate, many exposure, many outcome at the same time. Example, multivariate analysis of variance, maneuver, factor analysis, all the multi-dimensional scaling. They are example of multivariate regression analysis. So I think let me just say that so that people will know how to condition them. And why I started with the one that is categorical first, because chi-square is something that is common. People get to know chi-square. Though, when the people that from the time we spend on the chi-square, you know that people don't know many things about chi-square. And even the people that came for the training we did, you know that a lot of things that people didn't know, and how to run them, because what we do is we look at the background, even historical background also, then we look at the description, illustration, and logic behind it. Then we now see what example, we now solve example. Then we know how do we use SPSS to run it and interpret the result. And if somebody has been followed, you will not be lost. Somebody will say that all those things you are discussing is too advanced. But what is, you know, they want us to sit with the basic concept of statistics. Just be talking about population parameter and this. How long will you do that? We spend weeks on those ones. So it's time to move ahead. And if you have been following systematically, and if you really want to increase your skill on it, you come for the weekend training, because in the weekend somebody was asking, what's the difference between the weekend training and this one? I think this one is a short this election, but that one is a workshop, because we have time to demonstrate. It's the weekend, though we spend much time, even though on Zoom, we demonstrate. So, and people is very informative. So I think I will stop here. And the many people also, they will ask me, when I talk about it, they say that where is this something? Whereas I send the poster, the banner, I send it to the WhatsApp. People will see, send text to me. And when they see, I want to subscribe, I want to do this, and I send it on the it's on the WhatsApp group. If your number is not on the WhatsApp, you can chat your number. When you chat your number, I will put it there. And this, and we started this training last week. It's 2 weeks. I actually give 2 weeks so that people will not have excuse, because if this week you are busy, many of you know, many people have many things you are doing, you may come for the second one. We have done the first weekend. This second weekend will be tomorrow till Sunday from 6 to 8:30 in the evening. So if you want to make yourself available, because so for some people that don't have SPSS, I have to send SPSS for them to install, and I send the data file we're going to use to practice, also demonstrate. I mail it to them so that you know, I won't be mailing it here, so many people cannot do two things at the same time. So I mail it before. If somebody is going to have problem, you know, I will have resolved it before the time. Because many people come with a phone. You are coming for workshop, you are using phone. You can use phone for this one we are doing. So if you are really coming for workshop, why should you use phone? Use your computer, let the SPSS there, and you can call you can demonstrate. I can ask you to share, and ask you tell you with on your computer what to do. So it's not everybody that want that. If you don't want, no problem. The knowledge also, apart from you demonstrating it, the other knowledge is good for you. So I think I'll stop here. And these are what we have on the poster also. It's the same thing we have just discussed: T distribution, T test, non-parametric counterpart, all those non-parametric, and we're going to run them with test places also. The one sample T, independent sample T, pair sample T, confidence interval between the means and the interpretation. Man Whitney U, with kissing ransom test, with kissing sign rank test, median test, the one we just discussed, the interpretation of result. I think I will stop here. I know that people have questions. So I believe you have questions, you have chatted, but nobody is chatting. Nobody, I didn't see any chat. Okay. Yeah, you can still ask your question. You can ask.
No, but we can ask directly. Can we?
Yeah, you can ask directly. If somebody doesn't want to talk, you can send text, and I will just read. What do you say, sir?
Oh no, I can ask directly.
You can ask, sir.
You are talking about one drawback of a non-parametric is non-inclusion of confidence interval. Does the median have confidence interval, median test?
Yeah, if you look at it, it doesn't have. If you look at the median is a statistic. You can calculate confidence interval of median, no problem. But you cannot, because the median, they just use that median to divide them into two. I don't know if you understand me now. They are just using the median to separate, to divide them into cutoff, as a cutoff point, into those people that are below median and those people above median. After that, the median doesn't do anything there. I don't know if you understand me, sir. So he now turn everything to like a chi-square self. He just turn it to a contingency table for you to now run as if it's categorical. You see? Because it's a quantitative variable, the two of them in the two groups. But when you now use median to divide them into two, to split each of them into two, so it becomes 2 by 2 table, like a chi-square. That's why you see the chi-square is the statistics. Any other one? Thank you, sir. Any other comment or question? So that show that is very, very simple, very straightforward. Hugo, it's very straightforward because you said that is very confusing or it's very straightforward.
Straightforward.
It's too straightforward. Maybe next time I will not be so straightforward so that you can ask questions. Because
I'm interested in that your weekend class. So I'm going to.
What do you say, Hugo?
I'll do the usual because I'm actually interested in the weekend for this one too.
Okay, you didn't come
That's
for the first one now.
That's using SPSS.
This one is appetizer.
But if you look at it, yeah, the problem I have is that when at the session before we started the something, that was the first workshop I did. And the reason being that so that when you begin to talk about all these things, people will get acquainted because there are some rudimentary things you need to know about how to go about even sorting your this thing, splitting file. There are many things how to, and that was why I did the first one. So we see. I don't know if anybody. I will put in the platform if anybody is interested. If I can get response that many people are interested, maybe because that one can be a drawback. Because with the first after that one, when we did what do I call it, chi-square, many people that participated, when you ask them to open, they are prepared. I'm ready to tell the person what to do, but they are afraid. The confidence is not there to participate very well. What are the people that participate very well? The people that attended, I can tell you, they attended because when I did it, the people that attended, they had more confidence to, they just load it and they participated. And that was why I did it first, so that but you may want to be part of it without knowing, but me, the best for you to learn statistics is doing and reading, read, do. And that's how I learned statistics over the years. I do and read. There are many things I get to know while analyzing that I didn't see. It was I've gotten to know them before I even read about them in the book. I got to know them. Yeah. So Professor talking to them as a logout, is he around? Oh, he's there. He will remember.
I'm around, sir.
Remember that time in Lut now when we talked about the mean. They said the mean when Dr. Wosu presented our project. Our former chief already then came back to present.
Yes, sir.
He now said that the mean was greater than median and the standard deviation was greater than median. They said it's not possible. The lady said that was what so. But I've not read it in book, but because I've run a lot of analysis, I've discovered the reason for it. When you have outlier, the standard deviation will be more than the median, the mean. I got to know that while running analysis, even before I read about it in the book.
Yeah.
So that is why it's very good to read and do, So if it is to have somebody that is doing project, okay, let me contribute this one to your project, bring the analysis, just run it. Since initially you may not collect money, if you are not confident in what you are doing, you will not collect money. If the person you have done is not satisfied, at least you have helped, you have not collected his money. So the process, through that process, will be learning.
Yeah.
Before you know it, you become perfect.
Yes, sir.
Perfect in it. So that's just it. So what I would do is that
just a question, sir.
Okay, sir.
I think in that instance, it would be better to report the median instead of the mean. I mean, when the standard deviation is greater than the mean.
Yes. Well, it's good to report both of them. You report the median also. Yeah, you are right. It's skewed. It shows that it's skewed. Thank you, sir.
Yes.
So what we will do, I don't know. It depends on because I was planning the next weekend. I was planning the Hanover. But what I will do is I will quickly put it on the platform. Anybody that is in, if anybody is interested in that running. If we have enough people that are interested, we can just use that week to go back, because it will make many people to flow. So you can have as many people that want to learn how to move around the headspaces. Before we do that one again, if you do that for the people that have not learned it, so it makes them to come to speed with what we are doing. Otherwise, you just be hearing you are at loss. But there is a lot of people. There's Dr. Olagunwe is not even here. If we do this, he will not even allow me to sleep. He will be running the analysis. Immediately we leave the something. I thought everybody is sleeping. He will be running the analysis to see if those will be asking questions. That is how to learn it. Before you forget, you will though the steps are there. I put the step there, screenshot everything. Even in the slide, after the all the slide, we put the screenshot, the step. You can go and practice it. So I think I will do that. So I will do that. Let's see between now and that next week Monday, if a lot of people show interest in coming for the airspaces, so we can use next weekend to do the airspaces. Okay, any other comments?
No, it's the Hanover we want to.
What do you say, sir? What did you say? You have to unmute yourself. I'm not hearing you.
He said it's Hanover he wants.
Okay,
It's the Hanover model we want to surprise.
But I'm also interested in this PLT test for SPSS. The man with you, I'm interested.
This week, we started last week. We started last week. Last one to be this week. Yes? Go on.
Are you going to do this week? Are you doing this weekend?
Yes. You see, that is it.
Okay.
That is, we say
I just want to be sure. I want to be sure.
That's what I also presented now. People keep on asking me.
Okay.
That's what I also presented.
Okay, no, because I saw it on WhatsApp that you're doing this weekend, so I just wanted to confirm because I'm interested in that one.
So it's okay. So it's everybody that is interested. Have you resolved your computer issue? This is your airspace. I don't want you to use phone.
Back. Eh? No. Okay. I see what you. Okay.
You let them partition.
Okay, you told you. You told me to do partition on that MacBook, but I don't know how to do the whole partition.
It's not you that give it to people that no computer. It's not you that will do it. It's people that no computer. All the IT, go to the IT department in your institution. You see people that they will just help you partition it. You'll be able to. They will now install the airspaces on the Windows side, and you are up and down. That's what people do. So one app you use it for your map for a physics. The other one will be doing the real work, the window. Because as far as say any other comments.
Thank you, sir.
Okay, thank you, Prof. Okay, sir.
Good night.
Thank you, sir.
I think we want to appreciate your method of approach because you lay the foundation first before the real weekend training. That's super approach. Thank you very much.
Okay, sir.
Thank you very much. Good night.
Good night, sir.
Thank you very much, sir.
Yes, sir.
Good night, sir.
Good night, sir.
Thank you very much.
Okay, welcome. Thank you. Good night. Dr.
Thank you very much, sir.
Thank you.
Good
night.
Thank you very much.
Dr. Jacinta, thank you.